So hello, what's up everyone? In this video we will be solving Leetcode number 712. So let's understand what the problem is saying. So as you can read that in this problem we are given two strings S1 and S2, and what we need to do is we need to return the lowest ASCII sum of deleted characters to make two strings equal. So in this we need to make two strings equal such that the characters that we delete from both the string, their total sum should be minimized. So this is the overall problem, and let's understand how we can solve this problem and how we can approach this problem. So here's the example that I have taken. So what we can do here is, so let's say I'm particularly at this position and I'm at this position. Let's say this is my ith pointer and this is my jth pointer. So every time I have, let's say, three choices to make. So every time I have three choices. Now what are these three choices that I need to choose? Sorry for the writing, it's pretty, I don't have any pen. So the three choices that we have, let's say, where is the text button? Yeah. So what are the three choices that we have? So the first choice is to delete the ith pointer, the element at the ith pointer, element at the ith position basically. And the second choice is to delete element at the jth position. These are the two choices. Now what is the third choice? We want to make these two strings equal. So the third choice came, what if the two elements are equal? We don't want to delete that element, that particular element. So the third choice would be if the two elements are equal. That's our end goal. We need to make the string 1 and string 2 equal. So that's our main objective. So if the two elements, the element at the ith position of string 1 and the element at the jth position of string 2 are equal, we don't want to delete this, right? So if two elements are equal, we don't want to delete that, and we basically move our I and j pointer, I++ and j++, and this choice also, and this choice, the first choice, that we are deleting the element at the ith position, we will add that. What I'll do I++, and here I will do j++, right? And what I need to do is I want the minimum of all these three choices that I will make. So you can think of it as a recursive approach. So let's try to build the recursive solution first, and then we think of any optimization that we can do here. So let's write the code. I will write the recursion directly. So I need to return the sum, right? So the return type would be integer, so int, and let's call it recursion only, rec, and I want to make two pointers. I have two pointers, the I and j pointer. So int I and int j. Let's think of the base case. So what would be the base case? Now there is one base case, like if your I reaches m at the end. So if your position is out of bound, so then you need to stop. Or if your j is out of bound, that is n, so in that case also you need to stop. So these are your base case condition. And let's say let's do something. Let's say your j is at this position and your I is at this position. So you see that A and A are equal, so it lies in the third choice. We don't want to delete it, so we skip both of them. So I will move my J pointer to this one, and I will move my ith pointer to this one. So it has gone out of bounds. So at that particular time I need to stop. So this is the base condition. So I'll write if my I is equals to m or my j is equals to n. So in that case I want to return something. Now what I want to return, I'll think it later, but just let's just put it 0. I will think it later. So this is the base case that we have designed. Now how we can approach this. So I want the minimum, so let's consider long. Why I'm doing long? Because probably it will get out of bound, but let's just take it and we will see that. And sum, not sum, let's call this, yeah, sum would be great. So end sum. What I need to do, first choice is I want to delete the element at the ith position, and I want to move my I pointer to +1 position, right? So what I'll do, I'll say my recursion do the work for me, I +1 and j. And what I need to add here, I need to add the ASCII value of the character that I have deleted. So what character I have deleted? So I have deleted the s1th at the ith position, the string 1th ith position character I have deleted. Now this is my first choice. This is my first choice that I need to make, and the other choice would be sum is equals to minimum of sum, comma. I will say that in the second choice I will move my j pointer, I'll delete the jth character, and I will add the ASCII value. So this would be my second choice. Right, now for the third choice we have a condition that the third choice will only be applicable if my element at the ith position and the jth position are equal. So I'll put if s1 of I is equals to s2 of j, and that condition, my third choice, will be applicable. And what's my third condition is that I will skip, I don't want to delete that, so I will skip those elements. So what I'll do, I'll say sum is equals to the minimum of the sum that I have, comma, the recursion of I plus 1, comma, j plus 1. And I'm not adding any element because I haven't deleted that element, because I don't want to delete it. In the end I want to make the two strings equal, so that's why I'm not adding anything, this thing, and in the end I will return sum simply. So this is the basic idea of the recursion. Now let's consider what are the edge case that we can have in this. So the one edge case that I can think of that we can encounter, and that too is in our base case. What is that? That is, so we are adding and deleting elements and adding to our answer, but what if my let's say I have something like a b a c c d d. This is my string 1 and b c s s d d e f, like this. So let's say in this case my ith pointer is out of bound and my jth jth pointer is not out of bound. So if my the one of my strings, one of my pointer gets out of bound, so I want to delete rest of the element from the string too. That's only I can make. That's the only way I can make these two strings equal, right? So I need to delete all of them. So it doesn't make so much sense, the example that I have considered, but let's consider some good example. Let's take this one, delete and leet. So okay, so delete and we have leet. So let's say my jth pointer is here, it's out of bound, and my ith pointer is, let's say, at let's say at this position, right? So I wanted to make strings equal, right? So what I will do is I will delete all the elements from that particular index. I'll delete all the characters, right? So in this case also, if my I pointer comes out of bound, and let's say my j pointer is particularly here, it's not out of bound right now. So the common string would be e and a, and let's say I have found my common string, that is ea, but I can't simply return 0 because I need to delete this t also. So what I will do, let's write the code. So what I will do, I'll create one let's say temporary, int temp. I'm not good at naming variables, so don't mind. So let's call it 0, and I'll say while my I is not equals to m. So I'm considering that my ith pointer has not reached the end yet, and my jth pointer has reached the end. So this is the thing that I'm considering right now. So I want to delete all the elements from ith position till m. So what I will do, I'll say, okay, temp plus equals to the s1 of I, and I'll do I plus plus simply. Again, in this condition I am considering that my ith pointer has reached the end and my jth pointer hasn't. So I'll say if j is not equals to n, I'll go temp plus equals to s2 of j, and I'll say j plus plus, and in the end I will return the temp, right? Now let's try to run this. I'll initialize them globally, s1 comma s2, int m comma n. Okay, so x1, let's call this x2. So I'm saying s1 is equals to my x1, and my s2 is equals to my x2, and my m is equals to s1 dot size, and my n is equals to s2 dot size, and I want to return recursion of 0 comma 0, right? Now let's see. It should work. Yeah, it worked. Now let's see if it gets accepted, but it won't. It will probably give the TLE. So here what we need to do is we need to memorize this. So what we can do is we'll say int dp of, we have two changing states, we have two states, right? So that's why the 2D DP came into picture. So 1000 is the limit, and the other constraint is also 1000. To make it safe, I'll make it 1100. Good. And now the dp check dp of I is equals ij should not be equals to -1, and then if it is not equals to -1, then I'll return dp of I comma j, and I will store my dp of I comma j answer to sum. I'll do the memset dp comma -1 comma size of dp. That's it. Now it should get accepted. Yeah, it got accepted. So the time complexity would be n into m. Yeah, n into m. Time complexity is order of n into m, and it passes the test case. So that's it for the video, and this is the solution, and this is the intuition basically. I would recommend, this is a problem of DP, so I would recommend, if you haven't done DP, go check the DP, go and learn DP, and that's it. Thank you for watching the video. See you. Bye bye.